So hello there and welcome. By now you should have already learned that there are three major trig functions: sine, cosine, and tangent, and today we will work on another three. But before we do that, let's do a little warm-up to get us started. So here it says draw and label a triangle ABC where C is the right. So you want to make the triangle actually look like a right triangle. People do some funny things where there's no right angle and they just kind of force it happen. That is silly. So C is here. I'll put A here, B here. It doesn't matter. They could be switched. It says here that AB is 25. AC is 7. And there we go. Determine the missing side and label it on your diagram. So, as you can see, we're going to have to find the missing side would be BC. That's the missing side. Now, think about what theorem you can use to find BC. That's right. You should have A squared plus B squared equals, I like to just say h squared because the hypotenuse squared, but that's called the Pythagorean theorem. And you plug in the legs, so you realize one of the legs is 7. The other leg's the one we don't know. And the last one is the hypotenuse is 25, and that's being squared. So that's right, it's 49 plus BC, oops, I forgot to square that, is 625. So, BC squared is equal to 625 minus 49, because you subtract 49 from both sides. Ultimately, BC squared is equal to 576. Oops, I didn't mean that. Just get rid of it. So BC is equal to the square root of that. Of course, it is plus or minus square root, but it doesn't make sense for a negative value because that would make it a negative length, and we're not looking at that. So this is 24. So now I can go back over here and plug in 24. Okay. Now, you're going to use this diagram and find the sine of B, the cosine of B, and the tan of B. And here's a little reminder of those. As many of you guys are familiar with this, you may know it as so, ka, toa. Remember that sine and cosine have hypotenuse, are involved with the hypotenuse, and tangent is not. Okay, so sine of B is opposite over hypotenuse. So sine of B. Well, now think about what, you're going to go on your picture, and you're going to have to find what is the opposite and what is the hypotenuse. The opposite of B, here's B. That's your angle. The opposite of B is 7. The hypotenuse is 25. All right. So now the cosine of B is adjacent over hypotenuse. So adjacent to B would be adjacent. I'm going to use a different color. That's adjacent. That would be 24 over hypotenuse 25. And then tan of B, that's opposite over adjacent. Remember, we're using SOHCAHTOA. And tan of B would be, as we're now using that one, I'm going to write that down. Opposite, so opposite 7 over adjacent 24. And there you have it. That's where they are. Okay. So now that you know about sine, cosine, and tangent, it is my honor to introduce, that should be capital. It is my honor to introduce 3 more trig ratios. Now, they are called the reciprocal trig functions. Before I introduce them, let's make sure we know the word reciprocal. Have you ever heard that word reciprocal? And what word is usually associated with that? In fractions, we often call it the flip of a fraction. Sort of silly, I know, I'm sorry. But one of the things about reciprocal numbers is that if you have, like, example, 3 over 4, and you multiply by the reciprocal 4 over 3, you will get the multiplicative identity 1. These are the reciprocals of each other. They are the flips of each other. Okay. Now, let's get into this. The reciprocal trig functions come from our original function. So let's say you already know, let me use a different color for this. Black, I love this. So you already know about the sine of x, and that is equal to opposite over hypotenuse. And the cosine of x is adjacent over hypotenuse, and the tan of x is opposite over adjacent. So the reciprocal trig functions are the reciprocal of those fractions. So this one, as you know, that's sine. There's going to be something called cosecant. And cosecant is abbreviated by CSC of x. I can't stand when people don't put that in there. Of x is equal to, instead of opposite over hypotenuse, it's hypotenuse over opposite. And then we have cosecant, then we have secant. Okay, that is abbreviated SEC, but we say secant x. That's hypotenuse over adjacent. And then you have tan. This one has cotan. And it's abbreviated cotan, COT, is adjacent over opposite. All right? Yes, you know that's sine, that's cosine, and that's tangent. But these are the reciprocal functions. So you already know about sine, cos, and tangent, and some people call it sin, cos, tan. I find that very strange, but you know, if it helps you remember, I guess. But these are not. This is CSC is cosecant, secant is SEC, and cotangent is COT. I mean, you can say cot and sec, but it's super weird. But those are those the reciprocal trig functions. And let's use it for triangle. Example with triangle ABC in the warm-up. So in the warm-up, I'm going to just make it so you can see it. You have over there, the sine of B is 7 over 5. Well, what would the cosecant of B then be? 25 over 7. You just flip that. And you have, I want to see what the secant of B would be. Well, you have the cosine. It's 24 over 5, 25. So this is going to be 25 over 24. And cotan of B, if tan is 7 over 24, then cotan is 24 over 7. Some people get confused and think they're never going to remember all this. Well, there's a good way to remember it. If you know sine, cos, and tangent, those are the basic ones, then you know the reciprocal of sine will be the one that starts with a C, cosecant, just S and C. You know the reciprocal of cosine will be the one that starts with an S, the weird new sounding one that starts with an S. So the C and the S kind of switch. And tangent, well, don't go with that C, just go to the fact that they both have T's in them. And that might help you remember which is which. It definitely takes practice. Okay. So now we are going to be finding all 6 trig ratios for angle A for each triangle. So let's take a look at how that will be. So we have triangle where we don't know what x is. We're going to need to do that if we're going to find all 6 trig ratios. So I'm going to use my Pythagorean theorem. A squared plus b squared equals the hypotenuse squared. So a squared is x squared plus 4 squared equals 15 squared. So you have x squared plus 16 equals 225. X squared equals, subtract 16 from both sides. That's 225 minus 16. So you got to subtract it from both sides. X squared is equal to 209. X is square root of 209. And that's positive because the negative length would be weird. So there you go. I plugged that right in so it looks nice. And now I can find all of them. I will rationalize as needed, which is something we do in Algebra 2. So let's find the sine. I'm going to use a different color. Let's find the sine of A. And we're going to find all 6 of them. So first one is sine of A. So I'm going to go to A. And I'm going to think that's opposite over hypotenuse. So here's A. Sine of A is square root of 209 over hypotenuse, 15. Cosine of A is adjacent over hypotenuse. So cosine of A, that's right, you should have gotten 4 over 15. And tan of A is opposite over adjacent. So tan of A is over 4. Square root of 209 over 4 is what you should have gotten. Opposite over adjacent. So now you have all of those. Now let's get the others. So that would be why I have here sine starts with the S, so I know the other weird one starts with a C. It's not weird, but the reciprocal one. And it's not cos, it's cosecant. You get used to it. Cosecant of A would be the reciprocal of this. So it would be 15 over square root 209. Or you can think of it as hypotenuse over opposite, or you can think of it as 15 over square root 2 over 9. Any way you want to look at it. You just flip them. The only thing is it's got a radical in the denominator, and in Algebra 2, they are not fans of this. So we'll practice rationalizing. So you multiply top and bottom by the square root of 29. So cosecant of A will be 15 square root 209 over just 209. And there we go. Secant is the other one that goes with cos, is secant of A, 15 over 4. And cotan of A is 4 over square root 209. Same problem as before, so I will rationalize. So cotan of A is 4 square root 209 over 209. Okay, so moving on to number 2. Again, you are going to need to get that missing side, and this time it is the hypotenuse. So 6 squared plus 11 squared is equal to the hypotenuse squared. So that would be 36 plus 121 is equal to x squared. So that is 157. So x is equal to the square root of 157. Okay, so now we have to find the directions say to find all 6 trig ratios for angle A. So here's angle A, right? So you have to be able to identify the opposite, the adjacent, and the hypotenuse. Sine of A is 11 opposite over, of course that is not rationalized, so we will rationalize it by multiplying the numerator and the denominator by square root 157, leaving me with sine of A equaling to 11 square root 157 over just plain old 157. Cosine of A is going to have the same situation. Going to be adjacent over, it's also going to need to be rationalized. So cosine of A is 6 square root 157 over 157. And tan of A, well, that's just 11 over 6. Now, let's use a different color to get the other ones, the cosecant, because sine starts with an S, so this one's cosecant A. Now, I could do the reciprocal of this guy here, but then it would put a radical and it's just messy. This one's easier if you go to its original sign where it was, you know how it's opposite over hypotenuse. If you just think, oh, hypotenuse over opposite. So that would be radical 157 over 11. And that's easy. And secant of A, oops. Secant of A is equal to, and that one is, if you remember, instead of, you have to look at the reciprocal of cosine, but we can look at this one a little better. Square root 157 over 6. And cotan of A is the reciprocal of tan, so that's just 6 over 11. Okay, now we have those. Well, let's check out this other one here. We have, for angle A, again, we have the adjacent and the opposite and the hypotenuse, so we're missing some information, so let's get that. Plus the other leg squared, I'm going to use Pythagorean theorem, is equal to the hypotenuse squared. So 64 plus x squared, 256. So find out what x is. You should have gotten 256 minus 64. So x squared is equal to 192. So x is equal to the square root of 192. That can be simplified as the square root of 64 times the square root of 3. So that is 8 square root of 3 in simplest radical term form. So I put that there. Always good to do when you can. But let's get these. Sine of now A. You're going to need to know that it's opposite over hypotenuse. So that will be 8 radical 3 over 16. The hypotenuse is 16. So sine of A can be simplified. How nicely. A can go into that once, and A can go into that twice. So that's radical 3 over 2. Now let's figure out what the cosine of A is going to be. Cosine of A, adjacent over hypotenuse. So that would be adjacent, 8 over 16. So cosine of A is 1 over 2 when you reduce it. Okay? And let's get the last one. Tan, for the main ones, tan of A, opposite over adjacent. So that's 8 rad 3 over 8. In fact, tan of A can be simplified to just rad 3. Yay, we're done with those. So now let's go into the others. Let's get a color here again. So the reciprocal of sine of A is cosecant of A. And cosecant, instead of being opposite over hypotenuse, is hypotenuse over opposite. I can just look at that to figure it out and just say, well, that's just 2 over rad 3. Of course, you have to rationalize, so you just go ahead and do that, and you say cosecant A is 2 rad 3 over 3. And that's that one. Now let's get to the other ones. Cotan of A, not cotan, the one that goes with cosine, the reciprocal of cosine is secant of A. Secant of A is the reciprocal of this one. I can do reciprocal of 8 over 16, or I can do the reciprocal of 1 over 2. So I'll just say 2 over 1. So secant of A is 2. And lastly is going to be cotan of A, which is the reciprocal of tan. So we have tan to be radical 3. So the reciprocal of that is 1 over rad 3, because you can assume that that's over 1. So rationalize, of course. So cotan of A is 1 times rad 3 is just rad 3 over 3. Oh, no. That bothers me. Sorry. There we go. Alrighty then. Let's move on. Sometimes to find the values of, sometimes you don't even need to make a triangle. Like if they say this is the secant of theta, they say find the value of cosine theta. So cosine theta, if you remember, secant and cosine are reciprocal functions. Cosine's your main one, right? So if they want cosine theta and you have this as secant, then it's so simple. Cosine theta is just 8 over 15 because they are reciprocals. And here they're asking you for tan, and they gave you cotan. They are reciprocals. So tan of theta is the reciprocal of that, 7 over 1, or just 7. Right? And then over here, sine of theta, they give you 5 over 4, and they're asking you for cosecant theta. Is that the reciprocal of sine theta? Yes. So cosecant theta will be 4 over 5. Easy. Now, sometimes you do need to draw the triangles, right? So like they want you to find secant theta, but they're giving you sine. Are they reciprocals of each other? Is secant theta the reciprocal of sine? No, so we're going to have to draw the triangle. So to draw the triangle, it's great. All you have to do is identify sine of theta is opposite over hypotenuse. So you're going to draw this triangle. You're going to decide that theta is somewhere. I always just put theta on the bottom. Just me, I like to do that. And opposite theta is rad 3, while hypotenuse is 2. And now you can figure out what the missing side is so that you can find secant, which requires adjacent, which is hypotenuse over adjacent, because that is the reciprocal of cosine. So we might need to get cosine in order to pull this off, right? So let's find the missing side. I'm going to go and say I got rad 3 is one of the sides, squared. The other side's the one I don't know. I'll call it x. And the hypotenuse is 2. So rad 3 squared, these essentially cancel out. So that's 3, x squared, 4. So subtract 3 from both sides. You'll have x squared is 1. So x is positive 1. Could be negative, but not in geometrical figures. So let's take a look. I can put this now as 1, and I can solve this. I can find out, since secant is the reciprocal of cosine theta, it helps me to find cosine theta, right? So cosine theta is adjacent over hypotenuse. So cosine theta would be 1 over 2. So secant theta is 2 over 1, or just 2. Okay? That's just one way of doing it. You can also just think it's hypotenuse over adjacent, whatever. Any of those ways of doing it, just understand that you do need to draw a triangle and use Pythagorean theorem to help you. So now we're looking at cotan theta, and is what they want, but they give you cosine theta, and you know they are not reciprocals of each other. So again, you're going to have to draw a triangle. You're going to have to label what cosine is. Cosine is adjacent over hypotenuse. So 13 is my hypotenuse. I'm going to make theta on the bottom because I just like it there. I'm going to put 5 here. And I'm going to find out what this vertical missing side is. So I'll call it x. X squared plus 5 squared equals 13 squared. X squared plus 25 is 169. X squared is 144. X is 12. So you should have gotten that that's 12. So now you're able to find, you can figure out what the other parts are. So cotan theta is the reciprocal of tan theta, okay, which you know is opposite over adjacent. So cotan theta, if you want to do it that way, I'll do a little different this time, is adjacent over opposite of the angle. So cotan theta, adjacent is 5 over 12. That's all they asked for, so I guess I might as well just do it that way, right? Let's try this one. I don't know, that's not there. So sine of theta, find the value of sine theta if cosine theta is 24 over 25. Again, these are clearly not reciprocals of each other, sine and cosine. So you know this cosine can be known as adjacent over hypotenuse again. So I'll put my little theta on the bottom. The hypotenuse is 25. The adjacent's right next to it, so it's 24 in the bottom there. And you can figure out the missing side. Find the missing side. You do Pythagorean theorem is equal to 25 squared minus 24 squared, 49, 7. So now you can find, since sine of theta is what they want, and you know that that is opposite over hypotenuse, sine of theta is, that wasn't even using any of the reciprocal functions, 7 over 25. Now find the value of cosine theta if cotan theta is 1. They're giving you cotan theta. These are not reciprocals of each other, so I can't just flip it. But I got to figure out what this is. So remember, you know that tan theta is opposite over adjacent. So cotan theta is adjacent over opposite. So when they give you 4 over, when you give you 4, you can look at that as 4 over 1. So the adjacent is 4, the opposite is 1. So when you draw your triangle, here's theta, the adjacent is 4, the opposite is 1. And since I need cosine, and cosine requires hypotenuse, I'm going to need to figure out the hypotenuse. So that's 17 is h squared. So h is square root 17. So now I can figure out what cosine theta is. Cosine theta is adjacent over hypotenuse. So cosine theta is adjacent would be 4, hypotenuse radical 17. I can't leave it like that. I got to rationalize. So it's 4 rad 17 over 17. I'll write it over here. Okay. All right. So let's take a look at the last thing. The last thing they're asking you for is to determine all 6 trig ratios with the given information. All right? So these are, so you have this. So you got a sine of theta is 4 over 5. So identify. The opposite is 4. The hypotenuse is 5. This is nice because this is 4. Hypotenuse is 5. What's the other side, the missing side? If you know your Pythagorean triples, you will get that your missing side is 3. So that's a 3, 4, 5 triangle, right? So now they want you to find all 6 trig ratios. Well, I know that I already have sine, so I like to list it just because it's neat. 4 over 5 cosine theta is 3 over 5. Tan theta is 4 over 3. Cosecant theta is 5 over 4. Secant theta is 5 over 3. Cotan theta is 3 over 4. And there you have it. All 6 trig ratios. One more. So this one is secant theta. Secant theta. I mean, I got to figure out, I got to remember it's the reciprocal of cosine theta. which is equal to adjacent over hypotenuse. So secant theta is hypotenuse over adjacent. I'm going to write that down over here. So this here is my, oops, back. I'm going to use a different color too. This one's my, I did that again, sorry. This one is my hypotenuse, and this is my adjacent. So now I'll be able to draw my triangle and answer all of them. Here's theta, like him on the bottom. Hypotenuse is 13, adjacent is 12, and then I can find the missing side. What's the missing side? If you know your Pythagorean triples, you might realize that the missing side is 5. It's a 5, 12, 13 Pythagorean triple. So this makes it nice. So now I like to list it in order. You don't have to. That's just me. Sine of theta is 5 over 13. Opposite over hypotenuse. Cosine theta is 12 over 13. Tan theta is 5 over 12. Also remember that tan is sine over cosine. And so you can look at it as 5 over 12. Some people like to do that. Now we also have cosecant theta is the reciprocal of sine. Secant theta is the reciprocal of cosine. And cotan theta is the reciprocal of tan. And if you were able to do this, you're in good shape. Nice work. So the conclusion is this nice little diagram shows you sine, cos, tan, cosecant, secant, cotangent, as they're supposed to sound out as well. And remember, reciprocals are when two expressions have a product of 1. I hope this video helped you. Have a nice day.